A recent Canadian Retro Things video about BASIC09 has multiple screens running a program to show how fast BASIC09 is. It's a very effective technique. Let's try it with the 8 queens problem. Both screens will run MAME, emulating a Coco 3 with a 6309. Both programs will beep when they display a solution to give an audio cue. Sorry about the notification sound at about 3:56 on the Color Basic run. The Color Basic version will run with the double speed poke, and both programs use the same recursive algorithm and board data structure, so the language choice is the only variable. However, the BASIC09 version uses BASIC09 data types. Using types Color Basic lacks, for example integer or Boolean, is no more cheating than using BASIC09's superior control flow structures and procedures, which Color Basic also lacks. Here goes. While we wait for the Color Basic version to finish, let's talk about the representation of the board. Rather than the obvious 8x8 array of Booleans, we have 3 one-dimensional arrays. The first one answers the musical question, given a row number, which column has a queen? The other 2 correspond to the paths a bishop or queen can take diagonally across the board, one for those going up as you move left to right and one for those going down. Checking whether a square is under attack only requires checking one element of each array rather than walking along 2 diagonals and a row of a 2-dimensional array. By the way, if you look in Appendix A of the BASIC09 manual, you'll see an 8 queens program much like the one here. The board data structure is about the same, but no type is declared for it, and the printout of individual solutions isn't quite as fancy, not meriting its own procedure. Is our program I/O bound? Just beeping rather than printing the board only cuts the runtime down from 1 minute and 11 seconds to 52 seconds, so no, not really. Only a few minutes to go. To get the full effect, you really should let the video play. There is a brief discussion at the end. You made it to the end. If you watched the whole thing, congratulations on your endurance. Both the BASIC 09 and the Color BASIC versions take long enough that we can use a stopwatch to time them. Try it, and you'll find that the BASIC 09 version takes 1 minute and 11 seconds and the Color BASIC version takes 6 minutes and 6 seconds. The algorithm is the same. The output is the same. The clock rate is the same. Why is BASIC 09 over 5 times faster? First, all Microsoft BASICs on personal computers in that era perpetuated design decisions forced on them when RAM was scarce, at a dreadful runtime cost. With few exceptions, your Color BASIC code is as you typed it, and every single time a statement is executed, Color BASIC must convert constants from text to internal form, look up variable names and line numbers by linear search, and reparse expressions, complete with working out how parentheses and operator precedence influence the result. BASIC 09 immediately converts source code into a format with constants converted to internal form, expressions converted to easily evaluated RPN, and variables and parameters in forms not requiring symbol table lookup, avoiding all that runtime overhead. Second, the only numeric type Color BASIC supports is a 5-byte floating point type. When you can use integers, they're far faster, and the array subscripts and even the total count of solutions easily fit in BASIC 09's 2-byte, 2's complement integer type. Finally, maybe it's Color BASIC that's I/O bound. A YouTube video from a while back looked at a program that generated a lot of output on a TRS-80 and a Coco, and slow scrolling on the Coco made it come in a poor second. If you've seen the videos showing the improvements in Nitro OS 9 ease of use, you'll notice many serious improvements, including text output speed. To give an idea of the importance of the board representation, the 8 queens problem is one of the classic problems used to teach recursion, but what provoked this BASIC 09 version was Aaron Banerjee's article in the World of 68 Micros. The program in his article uses the 8x8 array, and he says, quote, "It is extremely slow. On a 0.9 MHz color computer, it takes several minutes just to find the first solution," end quote. If you're familiar with computational complexity, you'll know that the 3-array board representation lets you check whether a square is free and constant, order 1 time. For the 2-dimensional array, it's order n where n is the column number, making the algorithm as a whole order n squared or worse. Banerjee's article is a fine example of recursion elimination. This Color BASIC version takes advantage of recursive go subs. Perhaps this will encourage you to look into BASIC 09.